Confidence intervals for the population mean. The central limit theorem may be applied to form a confidence interval for the mean of a population given the mean of a large enough sample and a standard deviation. Suppose a population has a mean and a standard deviation. Also suppose that we have a random sample of size n greater or equal to 30 from this population, and that the sample has a mean of x bar. We would like to use this information to form a confidence interval for the mean, for example, a 95% confidence interval for the population mean. We may consider x bar to be a single sample mean from the distribution of all sample means of size n. Using the exact same argument as for the population proportion, there is a 95% probability that x bar lies in the interval the mean minus e, comma the mean plus e, i.e. that x bar is between the mean minus e and the mean plus e, where e is the margin of error. Once again, we reverse the argument. We can equally say that there is a 95% probability that the population mean lies in the interval x bar minus e, comma x bar plus e, i.e. that the mean is between x bar minus e and x bar plus e, again where e is the margin of error. The margin of error e is defined in terms of the standard deviation of the distribution of the sample means. This standard deviation is called the standard error of the mean, SE. From the last section, SE, which stands for the standard error of the mean, the standard error of the mean is equal to the standard deviation divided by the square root of n. And this is on page 34 of our formula book. Then, in general, the margin of error is given by E equal to Z multiplied by the standard error of the mean. So basically Z multiplied by this, where the value of Z depends on the confidence level. As we saw in section 1, for 95% confidence level, Z is equal to 1.96. It would be a good idea to learn this off because it is the most common. Thus, the 95% confidence interval for the mean is x bar minus 1.96 multiplied by the standard error of the mean, and x bar plus 1.96 multiplied by the standard error of the mean. So the mean will lie between these two values. Or you could say the mean is greater than x bar minus 1.96 multiplied by the standard deviation divided by root n, or the mean is less than x bar plus 1.96 multiplied by the standard deviation divided by root n. So 95% confidence interval for the population mean. A population has a mean and a standard deviation. Suppose a sample size of n greater or equal to 30 has a mean of x bar, then the 95% confidence interval for the population mean is x bar minus 1.96 times the standard deviation over root n, comma, x bar plus 1.96 multiplied by the standard deviation all over root n. So the mean will lie between this and this. It will lie inside this interval. In practice, if the standard deviation of the population is not available, then we use the standard deviation of the sample S in its place. A random sample of 64 13-year-old students was taken, and their weekly pocket money was recorded. The mean pocket money of those students was found to be €4.50, and the standard deviation was calculated to be 60 cents. Form a 95% confidence interval for the mean pocket money of all 13-year-old students in the population. So let this be the mean pocket money of all 13-year-old students. For the sample, x bar is equal to 4.5, s is equal to 0.6, and n is equal to 64. So we got all of this from the question. As the population standard deviation is not available, we use S instead of the standard deviation. So the standard error of the mean is S divided by root n, which is 0.6 divided by root 64, which is 0.075. So again, we're going to use our interval, which is the mean is greater or equal to x bar minus 1.96 multiplied by the standard deviation over root n, and x bar plus 1.96 multiplied by the standard deviation over root n. Now remember, we don't have the standard deviation, so instead we use S, so actually this value will be 0.075. Then, the 95% confidence interval for the mean pocket money of all 13-year-old students is 4.5, which is the x bar, minus 1.6 multiplied by 0.075, which is the standard error of the mean, and 4.5 plus 1.96 multiplied by 0.075. So this gives us 4.353, and this gives us 4.647. Thus, the 95% confidence interval for the mean is €4.36 to €4.64. Note that we round to stay inside the interval from 4.53 to 4.647. So we want to stay inside this interval, so it would not be accurate to round this up to 4.65. Although you would say, oh, well, the 7 will round the 4 up to 5, but then we're going outside the interval if we do that.